So worked example number 2. Let's do it over on the other board. So in this question, we have sodium hydroxide reacts with sulfuric acid to give me sodium sulfate and water. Start with our table. Okay. So mass, RMM, moles. What are we getting? In the reaction between 7.5 grams of sodium hydroxide and an excess of sulfuric acid, salt and water is produced, according to the balanced equation. Calculate the mass of sodium sulfate produced, so I want this, and the mass of water produced. Oh sorry, that's B. I don't want that one. So we need to figure out how we're going to get there. And we're told we have 7.5 grams of sodium hydroxide. Now, we're going to move across the board and find out how we're going to get over here. We're not told anything about the sulfuric acid, so we ignore it. There are some reactions where you will have to figure out which is the limiting reagent, and if you've done stoichiometry 2 in class, then you'll know what I'm talking about. If not, we're going to look at this later on, because the limiting reagent has come up twice before and both times it wasn't answered well. In this one, we're not told any information about the sulfuric acid, so we don't care about it, just ignore it. Right, we need moles. So first, work out the RMM. So the RMM for sodium hydroxide is 23 plus 16 plus 1. 23 plus 16 plus 1. Now, something from the balanced equation, and this comes up every year. When you are working out the RMM, you are only working out the RMM of the molecule. The 2 in front does not impact here at all. Do not take it into account in the RMM. We're going to take it into account with moles. Some people teach it to take it into account here, and I don't like it. It confuses things a little bit. So it's only the sodium hydroxide RMM. It's not 2 of them, just 1. So that's going to give me 23, 16, and 1 is 40. Now, to get moles, moles is mass over RMM. So mass divided by the RMM. Which is 0.1875. Now, that's the number of moles of sodium hydroxide that you need in this reaction. That's how many moles are in 7.5 grams. Next, and that's 3. We're going to use that to work out the number of moles of my sodium sulfate. You can do both of these at the same time. I'm just going to go after A first, and then we'll do B. So, the ratio. As you look at sodium hydroxide, there's a 2 in front. So the ratio of NaOH to sodium sulfate is 2 is to 1, because there's a 1 in front here. So that means if you started off with 2 moles of sodium hydroxide, you would only end up with 1 mole of your sodium sulfate, so it's half as much. Now, we didn't have 2 moles, we had 0.1875. And to find out how many moles of your sodium sulfate you have, you divide this by 2, because it's a 2 is to 1 ratio, which is going to be 0.09375. And that's how many moles of sodium sulfate are formed in that reaction. Now, if we have moles, we're going to work our way up to mass, and that's 3. Now the RMM, so this is a particularly nasty one. So 2 times 23 is 32 for sulfur, and then 4 times 16 for oxygen, which is 142. Don't do that in your head, do it on a calculator. Now, to find out your answer for A, it's going to be the number of moles times the RMM. Mass is moles times RMM, which is 0.9375 times 142, which is 13.3125 grams. That's how many grams of sodium sulfate form in that reaction, and that's your answer for A. So you get 3 marks for this bit and 3 marks for your answer. Now, next one. Water. We need to look at the ratio. So for sodium hydroxide, is to water. 2 moles of sodium hydroxide will react with the sulfuric acid to form 2 moles of water. So it's a 2:2 ratio. Now in maths, you know 2:2 is the same as 1:1. 5:5 is the same as 1:1. If you have 2 moles of sodium hydroxide, it makes 2 moles of water. So the number of moles is the same. So if we look at this, that's how many moles of sodium hydroxide it had. The number of moles of water is going to be the same as that. And that's going to get you 3. And then same as we did for this one, work your way up to the mass. So for water, again, it's only the molecule, do not look at the 2. So for water, you have 2 times 1 plus 16. Your RMM is 18, so your mass will be 0.1875 times 18, which is 3.375 grams. And that's your answer for B. Now, I know this is quite daunting to look at. I don't expect you to get this right off the bat, nobody does. But with practice, this does come. Particularly if you lay it out in a nice logical way, it's very easy to pick up marks here. Now, let's talk about the slip. In this question, if you didn't show how you calculated the RMM, and you put all the numbers into the calculator and it gave you the wrong number at the end and you got 42. And then you divide that by 42, then you're going to get a different number here. There. So let's do 7.5 divided by 42 is 0.1786. Now that's not the correct number of moles because your RMM is wrong. You're not going to get your 3 marks there. But that doesn't matter. Well, it does, but it's not going to impact the rest of the question. If you have calculated the wrong number of moles because you've made a mistake, but then you use that over here. So instead of 0.1875, you 1786 and then half of that and follow it up. Your mass will be out by a little bit, but you're still going to get 9 of the 12 marks. So don't panic, just follow it through. If you think you've made a mistake, just continue with the question. You could still get most of the marks out of it. Let's talk about a slip. When you write out the RMM, so you've got 23 plus 16 plus 1 is equal to 42, and then it's the mass divided by the RMM, which we worked out was 0.17. Now, in this scenario, yes, your final answer will still be wrong, but now you've only lost 1. You will get 11 out of 12 marks. because your examiner can look here and see where your mistake was. So if I was correcting this, I would just go like that, and then your whole thing, you would still get 11 out of 12 marks. No, your number of moles is not correct, but that doesn't matter. Your method is fine, and I can see where the mistake was. Whereas if you don't show your workings, I can't see where that 42 came out of, and I don't know that you just made a very simple mistake with your calculator when you were adding them together. So just be very careful with that you show everything. Right. So now we're going to have a look at an actual exam question and how you can use this to maximise your marks in the exam. So on page 35 of your notes, there's an exam question from 2017, and it came up in the experiment section, question 2, part E. So now it's actually for quite few marks, which is annoying, but we worked with it. Okay, so the question is, the mass of calcium carbide consumed in the preparation of ethyne was 3.2 grams. So this is calcium carbide, you used 3.2 grams of it, reacted it with water to form calcium hydroxide and ethyne. Calculate the maximum number of ethyne molecules produced in this reaction. Now this goes back to here. We need to work out molecules. But to get molecules, we need moles first. So to start off with your table, no, you're not going to need to fill in all of it, but it's good practice to draw it anyway. So let's start with our calcium carbide. To get the number of moles of calcium carbide, we need the RMM first. So calcium is 40 plus 2 times 12, which is 64. So the RMM of calcium carbide is 64. The number of moles is mass divided by RMM, which is 0.05. Now, in this reaction, we used 0.05 moles of our calcium carbide. Now, we need to use this to figure out how many moles of ethyne that we formed in this reaction. So now look at the ratio. It's the ratio of calcium carbide, CaC2, is to ethyne. Now, from the balanced equation, it's 1 is to 1. 1 mole of calcium carbide will make 1 mole of ethyne. So however many moles of this you have, you're going to make the same number of moles of ethyne. So that means if I start off with 0.05 moles instead, you're going to make the same number of moles of ethyne. We know the number of moles. From there, once you know the number of moles, you can work out molecules. Because it's the number of moles times Avogadro, which is 0.05, 6.02 by 10 to the 23, which is 3.01 by 10 to the 22. And that's how many molecules of ethyne are formed in the reaction. Now, a breakdown of the marks. You would have gotten 3 for the number of moles of calcium carbide, 3 for the number of moles of ethyne, and then 2 for your final answer. So overall, it's not that bad of a question. Now, let's look at another one. In 2014, a particularly nice one came up. And you'll find this one on page 36 of your notes. When crystals of ammonium dichromate are heated strongly, they decompose fully according to the following balanced equation. When 12.6 grams of these crystals were heated strongly, calculate moles, mass, and molecules. So let's write it out. H4, 2. in this one, we need to work out how many moles of ammonium dichromate reacted. So this is number 1. Then we need the mass of chromium 3 oxide formed. So this one. And then it skips to part 4. So part 3 actually relates to I think it was the volume of nitrogen formed, which we're not doing yet because we haven't done the gas laws, but we will in the next one. And the number of molecules of water produced. So I'm going to put that as this because we're going to continue from here to get molecules. Okay. And what are we given? In the question, we're told that we had 12.6 grams of our ammonium dichromate. And we need to use this to fill in the blanks. Now, we're not asked for anything at this point for nitrogen. I don't want any of this, because I don't need it. I don't need the mass of water produced, you're not asked for it. So anything you don't need, you can just leave it blank. Now, to get from here to here, you need the RMM first. Now, this one in particular, please show your workings. It is not the nicest one, and it's very easy to make a very simple mistake here. Now, for the RMM, that 2 multiplies everything in here by 2. So for your nitrogen has a mass of 14, and there's 2 of them. Plus hydrogen, there's 4 in there already, times it by 2, that means there's 8. Plus chromium, there's 2, and chromium has a mass of 52. And then oxygen, there's 7 of them, and has a mass of 16. So your overall RMM is 252 grams per mole. If I know mass and RMM, I can work out moles. So it's 12.6 over 252, which is 0.05 moles. So that's gotten me 3 marks. So that's how many moles of our ammonium dichromate were used for part 1. Now, use this to find how many moles of your chromium 3 oxide were formed. Now look at the ratio. It's the ratio of NH4 to Cr2O7 is to Cr2O3. Now, I know these look quite complicated. It doesn't matter. It doesn't matter what they are. It could be X and Y. It doesn't matter. 0.05. Because it's 1 is to 1. 1 mole of this will form 1 mole of this. So however many moles of the ammonium dichromate you started with, you're going to end up with the same number of moles of your chromium oxide. So that's your answer. That's how many moles of your chromium oxide. And that's 3. Now use this. Let's work our way up to the mass. We need the RMM. So chromium is 2 times 52 plus 3 times 16, which is 152. So the RMM is 152. Now mass is moles times RMM. So it's this times 152, which is 7.6 grams. And that's another 3. Next one. Oh, sorry, I had a mistake over here. They were actually giving this for 6 marks. So 3 marks for that and 3 marks for your final answer. For the next bit, for part 2, you got 3 marks for the moles of chromium oxide and 3 marks for the final answer. They were giving away more marks than they usually do. Next, the number of molecules of water. Now, to get molecules, you need moles. So first off, we need to find out how many moles of water were formed in this reaction. And the ratio will give me that. So we need the ratio of ammonium dichromate to water. So look at the number in front. It's 1 is to 4. You start off with 1 mole of ammonium dichromate and you end up with 4 moles of water. So you have 4 times as many. We didn't have 1 mole. We had 0.05 moles. So to find out how many moles of water, times that by 4, which is going to give me 0.2. That's I'll get you 3. Okay, molecules. Take this and get molecules. So molecules will be 0.2 moles of water times Avogadro. So your number of molecules will be 1.204 by 10 to the 23. Then, that's 3. After that, they wanted you to work out how many atoms did this have. Now water is H2O. There's 3 atoms in water. So you take the number of molecules and you times it by 3. And that's going to give me 3.612 by 10 to the 23 atoms. And that was for, I think it was just for 1. Or they did 2 and 2. Now, for these, it's just important that you practice them. In the notes, I've given loads of sample questions and the answers are at the end with the mark schemes. All of my notes with the calculations, there's loads of practice questions. And I like to lay it out like this. I do titrations in a similar way because titrations can be quite difficult to get your head around, particularly when you're not allowed to use the formula anymore for it. So try your best to get your head around this first, and if you can do this, you're going to fly with titrations. Titrations are not as difficult and as mystical as everyone makes them seem. If you can do this, you're going to fly through them. Okay? Now, and I'm not going to go through any more of them, but there are quite a few samples in the booklet, so please, 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 please practice them. Now, tips for this part of your exam. I'm going to say it again. Show your workings. It's really vital that you show your examiner everything. You're in a high pressure situation. You need to do a large amount of work in a relatively short space of time. You can very easily make a very small mistake, but you want to try and ensure that you're going to get as many marks as you can. And so to do that, you need to show your examiner everything in the calculation. No shortcuts. And I'm saying that as someone, I corrected a H1 paper in 2019 and someone did out a question like this, did it exactly like this, and all I had to do was go, yes, 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 done, move on. And I could see very clearly that they had the right stuff there. For other people who had done the same one, it was quite messy and it took me longer to correct. Please, just to have it nice and neat, spell it out for your examiner. Don't have them wondering. We don't want to accidentally not award you marks because we couldn't see it. Okay? We're there to give you as many marks as we can. Right, so anything else? It would be a good idea when you are doing the calculations to put your formula triangle or the formula somewhere on the paper that you can just refer back to it and that it's fresh. Next, something else I would practice is go through the questions that I've done again today and see, can you do it without looking at the answer? Now, I know some of you will find this quite simplistic. Great, you're going to fly through the rest of it. But it's not as easy as it sounds. Like, I found this really, really, really hard when I was in school. And breaking it down like this is going to ensure you can get the best outcome. Okay? Now, for anyone who is interested in chemistry primes, they're going to run on 3 days. So we have, I'm just double checking so I don't get the times wrong. They're going to run on Monday, evening from 8 to 9:15. They're going to run on Wednesday, same time, and Saturday, and they are 9 to 10:15, so you guys get the early slot on Saturday. I'm going to be taking the 3 of those. So I will give you very detailed notes. My notes, I've spent years on them. My English ones are beautiful, and so are my Leaving Cert ones. So particularly my strengths are in the calculations and laying it out to maximise marks. Calculations and definitions are my 2 go-tos with your exam. There's no shortcuts with them, you just have to get through them. And little tips and tricks along the way of how to simplify stuff, and there's a really nice shortcut in organic chemistry calculation for thermochemistry that is a really nice one. You still get full marks even though you have to do half the work. The difference would be 1.5 pages of work versus 2 lines. So, and knowing those tips and tricks and where you can cut corners and where you can potentially save mark or save time is going to all add up in your exam. Okay, so I hope that was helpful, and best of luck.